Hello everyone, my name is Minghao Chen. I'm glad to present our paper, DGE Direct Gaussian 3D Editing by Consistent Multi-View Editing. This work is done by me, Dr. Laina, and Professor Andrea Vedaldi at the View Geometry Group at the University of Oxford. Let me first give some background information. Recent breakthrough in text-to-3D generation has drawn great attention in our community. There are a lot of great works such as Dream Fusion, Prolific Dreamers, Fantasia 3D, and also 3D editing with text instruction is possible with the help of 2D priors such as diffusion models and clip models. There are some results from 3D generation method and 3D editing method. In this work, we focus on 3D editing with text instructions. Most of the previous 3D editing methods usually iteratively update the given 3D representations, such as neural radiance fields, either through individual view edits or score distillation sampling. Take a representative work, instruct nerve to nerve as an example. Give a 3D model. It first sample one view and use a 2D editor to edit this view following the instruction. After get the edited image, the method uses it to update the 3D model. This loop will happen a lot of times, which makes it actually very time consuming. Such a 3D edit will take over 1 hour to achieve. How can we save the editing time? The main problem of previous methods is that they require editing a lot of time since the edits are inconsistent across different views. So what if we can get a consistent 2D editor? Then the 3D editing process becomes super easy. It is 2D multi-view editing plus a 3D fitting. Therefore, we propose our DGE. Given a 3D model, we first sample n views together, and then we feed these views into a consistent 2D editor to get n consistent edited views. After get these edited views, we feed 3D Gaussian directly on those views and get an edited 3D model. The big challenge here is how we can get multi-view consistent 2D editings. In our process, there are 2 steps. Step 1, we will first edit the keyframes. Given a bunch of input views, we first sample different key views and send them together to a modifying 2D editor. We use instruct pix2pix as our base 2D editor and modifying it with a new spatial temporal attention layer. This layer will make sure that edits between different key views are roughly consistent. The figure on the right of the slide is an illustration of the spatial temporal layer, where in the layer, the query of different images can attend to the key and value of other views. After editing the key views, we go to the second step, which injects the features from the key views to other views. We take out the self-attention values from the key views and inject into the self-attention layers of the other views. Specifically, we use epipolar line as our 3D geometry constraints for the feature injection. Given an image and the point of interest, we first find out the 2 closest keyframes and its corresponding epipolar line on the 2 frames. And then we compute the similarity between the features following the epipolar constraints and inject the feature of the keyframe to the current frame. After the feature injection, we can then get consistent multi-view editing. Once we get the edited views, we then directly feed the 3D representation to it and get the edited 3D model. Here are some comparisons with the state-of-the-art methods. Our DGE can produce editing results with detailed texture and produce reasonable results given complicated editing instruction. Here are more editing results. In addition, our method is based on Gaussian splatting. We can then further constrain the editing to a specific area and achieve partial editing. As an example shown here, we only modify the biggest skeleton without changing the rest of the scenario. Here are more examples of partial editing. We only change the color of the vest or the color of the dollar. Thank you for your listening. You can scan the QR code to find out our project page, and the codes are all open sourced now.